I did. Okay. So at the bottommost point, we have Vx and we have R omega dash. That is the point. So if Vx minus R omega dash is greater than equal to 0, that is, slipping didn't stop. The friction was not strong enough to stop the slipping. Slipping continued or didn't stop. And that is what you did actually. You assumed the friction was acting for the entire time dt. Then my answer is right. Then, yeah, whatever you got was right. Then your method was right. But if your Vx minus R omega dash was less than 0, this implies slipping stopped somewhere in the middle. So, great, right? So, matlab, friction stopped acting somewhere in the middle, and therefore F became 0 due to the middle of the collision. Now, again, not really tough, but you have to keep this in mind. So then what? That means now the equation becomes integral f dt dash is equal to mvx. This would be your equation 3. So there, unfortunately, we can't solve this, but you don't need to solve. You got a new equation. What is the new equation? Vx became equal to r omega dash. Na? If the slipping stopped, it means what? Vx became equal to r omega dash. Make sense? So this would be your new equation. Got this? So now what equations do you have in your hand? You have this angular momentum, and we have Vx is equal to r omega dash. Done, right? With that, you can solve. You cannot use equation 2 and any 3 and any more. 2 and 3 are useless. Are not usable anymore. So we just solve 4 and 1. That will give you the answer. Are you clear with this thing? So if you see, the idea was the same, right? In the previous case, when Vx became less than 0, the friction stopped acting. But here, because there's a rolling also involved, you should say Vx minus r omega dash. If less than 0, then the slipping stopped. All clear with this? And once you got Vy and Vx, you are done, right? You can use projectile motion. This is the time of flight, 2 Vy by g, and this will give you the range. You can do all those based questions. All clear with this? Arush? Clear, na? Then let's see one.
सर
Sohan.
एंगुलर इम्पल्स जो लिखा है वो नेगेटिव साइन के साथ होना चाहिए.
Angular impulse, minus होना चाहिए. Yeah, right. Next one. So that is one model on angular impulse. You can have it in collisions or you can have it in rotation based. The rotation based is a better one. Top view. You must have seen this question. Standard model. So we have 3 identical balls, M, M, and M. This is a top view, so these are a smooth floor.
If Vx equals to R omega, then would the,
Hmm.
so in that case, would Vx be 0? Then it would go upwards.
Come again. Vx will be?
Would Vx be 0?
Why Vx will be 0?
Because when Vx will be equal to R omega, friction would assume that the particle at that point is not moving now. So, so Vx be 0. Acha, okay, no, I got it.
Yeah. So we have 3 balls here. The length of the string is L, and L. I'm sure you have seen something like this. Class notes में भी किया था हमने. अच्छा question था ये. It becomes good because of one thing. Are you able to see the picture? We have 3 balls on a floor, straight line. Length is L and L. Massless strings. All the 3 balls are identical. So when you give the velocity u, what will happen? The middle ball will start going like this, and these 2 balls will come like this.
Laptop there. Can you just
And eventually, right, at some point, the system becomes like this. The ball A and C are about to collide. Find the tension in the string. So this tension will be T. Find tension in the string when A and C are about to collide. just before A and C collide. Is the question making sense? If you kick the middle ball, the other two A and C are at rest initially. If you kick the middle ball, it will start going front. In this process, it will pull A and C together. So A and C will try to go swing and they try to hit each other. So just before hitting each other, find the tension in the string. Meaning, if it was a paragraph question, I'll ask you find the velocities of A, B, C just before collision and find the tension in the string. That will be my two equations if it's a paragraph. So you need to find the velocities. Start from there. That is the standard model. The tension part is interesting. No, B is given speed u, bus. That speed is changing. This is the initial speed. B is given initial speed u constant nahi hai. So you just kicked u and left it. So B also will slow down. You get the velocities that you need. Without that, anyway, you can't find tension. So okay. Okay, get the tension also, na Aditya. Vihan. Let's see, Vihan. मुझे answer idea नहीं है. I have to check. Okay, mu square by 3L, mu square by 9L. We have two different answers. First, let's see the velocities part. By now, you should have figured out the velocities. If they ask you this thing in the exam, and if they ask you to find the tension and the velocities, so you should start. Matlab, you should know what to do. Tension, you can still get stuck. I can understand. Velocities, no. So first thing, this thing will be Vy. This thing also will go with Vy, and this will also go with Vy. Why? Velocity along the string must be same. If all of them don't have same vertical velocity, the string will either stretch or break. On top of it, A and C will also have a Vx and a Vx. Make sense? And you might ask, like, oh, how did they get the horizontal velocity? Think about this. While the thing is moving, tension is acting at an angle, right? So that will create both Vy and Vx. So the balls A and C will have two components, and because of symmetry, B will keep going straight line. So yeah, you're done. Conservation of momentum, conservation of energy. Mu is equal to 3mVy. Vy is equal to u by 3. Since there are no external forces, energy is conserved. Half mu square is equal to half m Vx square plus Vy square 2 times for A and C plus half m Vy square. This is for A and C and this is for B. Vy is u by 3, so cancel half m, that will be u square. That will be how much? 3 by 2 Vy square. Half m will cancel, half m will go off. That would be 3 Vy square plus 2Vx square. So Vy square will be u square by 3. That would be 2u square by 3. So Vx is equal to u by root 3. Check your speeds. This is the standard thing. इतना तो आना चाहिए. Energy and momentum. Now, from here, listen carefully. You want to find tension. So my first question is this. What is the path of A? Is A going in a circle? Yes or no? A is not going in a circle because it's going straight also. It is trying to go also. Fine. But who thinks A is going in a circle? There is one guy who still thinks A is going in a circle. B. Isn't it? B is the only person who thinks A is going in a circle. That means if you take an observer and make him stand on point B, and if you ask him, boss, what is A doing? He will think it is going in a circle. Okay, great. Now, but if you just look at B himself, what are the forces acting on B? We have a tension, we have a tension. So B is still decelerating, getting it? And this will be the acceleration of B. So 2 times tension will be mass into acceleration of B. Fine. So if you ask this observer, boss, what A is doing, he will say, okay, what are the forces acting? Tension. And because you are going in a circle, there will be a centrifugal force, mu square by L. This is the centrifugal force because you're going in a circle. We will again talk about pseudo forces and centrifugal forces in circular motion. There are actually 4 types of pseudo forces. For now, let's not worry about it. Now, not only this, tell me one thing. Is B an inertial frame? When the observer is standing on B, B itself is accelerating. So B is non-inertial frame. So observer will say, okay, since I'm standing in a non-inertial frame, I also have to apply a pseudo force, which is mass of the body, acceleration of the observer in the opposite direction. So B acceleration is downwards. So pseudo force will be in this direction. This is MAB. This is called as linear pseudo force, which you studied in NLM. This is your pseudo force basically. So centrifugal force is also a type of a pseudo force. So this body A will have 2 pseudo forces. Is that making sense, everyone? Because see, if you stand anywhere else, it is not going in a circle. If it is not going in a circle, we cannot use centrifugal force. But if you go and stand on B, you have to apply non-inertial frame. So you have to apply pseudo force. This velocity will be mvx square. And you're done actually. Bas itna hi tha. Matlab, yeah, it looks easy, but you should figure that out. So T plus MAB is equal to mvx square by L. What is MAB? MAB is 2T. So this is 3T. What is Vx? U by root 3 ka square. So tension will be mu square by 9L. Yeah, right, we have. If you forgot the pseudo force, I think you'll get mu square by 3L. Are you clear with this? If you want to use centrifugal force, it should go in a circle. The only person who thinks you're going in a circle is B. But the moment you go and stand on B, it's a non-inertial frame. You have to apply pseudo force. Is the idea clear? No, something better. We can do even better than this. We got a rod here, 2M, 2L. This is the top view. Here we have a ball of mass M. This is given speed U. This is a string of length L. This whole setup is placed on a smooth floor. Initially, this is 90 degrees. Now, if you hit this ball with U, what will happen? The rod would become something like this. The rod will start bending and this ball will start becoming something like this. Making sense? So the rod will also start turning. And let's say when the ball goes and hits the thing, E is equal to 0. It's a perfectly inelastic collision. The ball will stick. Find the tension in the string at T0 initially and find omega of the system when the ball sticks to the rod. So we have our rod. At the end of the rod, you kept a string. In the string, you connected a ball of mass M and you gave a speed U. At that instant, the moment you gave the speed U, find the tension in the string. And this ball goes and hits the middle part of the stick and gets stuck because E is equal to 0. Then what is omega? The second part is easy. I want you to find the tension. So this and the previous one are kind of related, but here I added rotation. Find the tension in the string at T is equal to 0. final omega of the system and the ball gets stuck. Now, whenever you see these kind of things, right, the first instinct you get is, oh, it's going in a circle, तो mu square well डाल देंगे. Fair enough. Then the second question should be, does everyone think it is going in a circle? Then the answer will come, no. Then you will ask yourself, okay, then who will think it's going in a circle? Then go and stand there. Start like that. See, that is what you will be thinking. You keep asking questions and you keep answering. When you do that, it is called thinking. You keep asking and someone is answering, it's called spoon feeding. So that's the only difference. Think, I'll give another minute or two. Tension you can find. I'll send you the extra questions anyways today in the group. So, sure, you figured out, right? Who thinks it is going in a circle? Who thinks it is going in a circle? This corner point A, if you stand there, you think it is going in a circle. Agreed? Now, so if you try to draw the FBD, what are the forces? Tension. And since A thinks you're going in a circle, there will be a centrifugal force. And also there will be a pseudo force, which is mass into acceleration of A. Itna clear? Yes, that was a whole story. That is the main thing there. If you go and stand on A, there will be two pseudo forces, a centrifugal force and a linear pseudo force. So next point is we have to find the acceleration of A. So when you take this rod, what are the forces acting on the rod? The only force acting on the rod is the tension. This is a top view, smooth floor. There is no mg. Fair enough. So what are the accelerations? A com and alpha. So tension is equal to mass is 2m into A center of mass. Then torque about center of mass will be tension. Length of the rod is 2L. So T into L is equal to I com, which is 2m 2L whole square by 12 alpha. So this will give me T is equal to, that is 2 ml square by 3 alpha. That's your tension there. 2 ml alpha by 3. Perfect. Then, now since you're rotating, this point A will have how many accelerations? So this point will have A com. And this point will also have, because of rotation, L alpha, because remember this length of the rod is L here. So acceleration of A is A com plus L alpha, translation plus rotation. You're done. So here we'll get tension plus mass into acceleration of point A is equal to mu square by L. So tension will be mu square by L minus mass into acceleration, which is A com. Actually, I'll keep it here only. What is A com? Acceleration of A is A com plus alpha. So tension plus m into A com plus ml alpha is equal to mu square by L. But what is MA com? MA com is T by 2. T plus T by 2. What is ML alpha? ML alpha is 3T by 2 is equal to mu square by L. That would be T by 2 plus 3T by 2. 2T, 2T, 3. So T is equal to mu square by 3L. Clear with this? Mass of the rod is 2m. Be careful. Maybe you're using m somewhere and 2m somewhere. Check the calculations. I could have messed up the calculations also. But is the concept clear, everyone? So the only difference between this and the previous question में alpha नहीं था, इस question में alpha था extra. This is a superior question than that one. Clear with this? This is something you will notice. Every that collision questions and momentum questions, right? You can add always a twist of, a rotation to it, and you can make it a little higher. Any doubts on the process? So there'll be two pseudo forces there. That is the key thing there. So the question always comes that way. Where are you standing and where are you seeing it from? Clear? Next thing. Let's see. Theta, this is mu, height h. Solid sphere released from rest. Find a mu minimum for no slipping. If you leave this ball on the incline, find the minimum friction for no slipping. Final omega of the system of the ball. You can calculate that. Oh, easy tha. How will you find final omega of the system? So this is there. This is M and this is going with U. So in this process, if you see this is 2M and this is M, so the center of mass will be somewhere here. And if you observe something, no matter what happens, the center of mass ka velocity is constant. Meaning no matter how the ball goes or no matter how the rod moves, the center of mass will always go with a constant velocity. This point is just going in a straight line. So this whole setup will move in such a way, the center of mass will follow that red line. Making sense? So when the thing collides, how will they collide? One thing is clear, the ball is colliding exactly in the middle of the rod. That means the center of mass, this is how it will collide, isn't it? If the ball hits the middle of the rod, where is the new center of mass? Middle of the rod, isn't it? So that means this position must be the center of mass. And this whole setup is going with u by 3. And the whole thing is rotating with omega. So which point is good point to conserve angular momentum? Center of mass, isn't it? You can actually take any point on this line, you can conserve angular momentum. So angular momentum about center of mass. I won't say exactly center of mass, but yeah, take any point here. Let's call it A. L about A is constant. So what is the initial angular momentum? This distance will be 2L by 3. The center of mass divides in the ratio 1:3. So M into U into 2L by 3 is equal to final angular momentum will be I of the rod plus I of the ball. Omega. Ball will be 0 because it's a point particle and rod will be 2m 12 whole square by 12 omega. So you'll get it from there. Clear with this? So the main key thing is the center of mass will continue to go in a straight line because it's difficult to see the path of the ball. It's not going in a circle. It's going in some pretty weird path, matlab. But yeah, the center of mass is safe. Got this? Yeah. Clear na, Akash?
Yes, sir.
Let's get this thing. Find a mu minimum for no slipping. We keep hearing, right? The ball is not slipping. Great, but how much friction do you need for no slipping? Second thing, if mu is half of mu minimum, then the ball will slip. Find V omega when it reaches the bottom. Find work done by friction. Find work done by torque due to friction till they reach the ground. Torques also do work. What is the work done by torque? Torque integral torque d theta. What is power due to a torque? Torque into omega. So F into ds becomes torque into d theta. Power F into V becomes torque into omega. So find work done by torque due to friction. Both are two different things. Till it reaches the bottom. I'm more interested in C and D actually, but to do that you need B. Get the mu minimum. That is the mains question. Find the minimum required for no slipping. That will be mains. Tan theta by 3. Vihan got 2 tan theta by 7. I'm not sure. Figure it out. I'll give you 2-3 minutes. Get me the equations. Mm, 2 tan theta by 7. That's your mu minimum. Now you're giving half of it. So it will slip. So normally the question what would have happened? You would have just conserved energy to find V and omega. That is the case when you're not slipping. If you're slipping, then how do you handle it? Let's see the first part. You should have got the mu minimum and the V and omega by now. So when the ball is going here, what are the forces acting on the system? Normal reaction, friction, mg sine theta, mg cos theta, acceleration, alpha. So since it is not slipping, you can take the torque about A. That is one of the best point there. Torque about A will be only due to mg sine theta. Into R will be moment of inertia about A, parallaxis theorem, 2 by 5 mr square plus mr square 7 square alpha. So this will give you A is equal to 5g sine theta by 7. Then we get mg sine theta minus friction is equal to ma. This will give you friction is equal to 2 mg by 7 sine theta. And we know friction must be less than equal to mu mg cos theta. And this will give you mu must be greater than or equal to 2 by 7 tan theta. This is your mu minimum. And now you're coming and telling me mu is 1 by 7 tan theta. So one thing is clear, there is slipping. Even then it is fine. If it is slipping, that is also okay. Because I know F max ka value. If there is slipping, then the friction ka acceleration will be simply g sine theta minus mu g cos theta. Mg sine theta minus F max is equal to ma, isn't it? There is slipping and therefore F max is mu mg cos theta. Acceleration aa gaya. Now you can't take torque about A, you have to take about torque about center of mass. So torque about center of mass will be it will be only due to the friction, which is mu mg cos theta into R is equal to 2 by 5 mr square alpha. Now A is equal to R alpha condition won't be satisfied because it is slipping. So you'll get alpha from here, you'll get A from here. There you got A separately and alpha separately. Right? You can substitute mu ka value there 1 by 7 tan theta. Yeah, you know A and alpha. Then what? If you know A and alpha, unfortunately there's no direct relation between them. So this is height h. This guy will be h by sine theta. I can use kinematics. S is equal to ut plus half gt square, half at square. The displacement is h by sine theta. Initial speed is 0. Acceleration will be a, which we just found out. From here we get the time. This is the time taken to reach the floor. Once we got the time, then I can use omega final is equal to omega initial plus alpha t. Omega final will be alpha t, omega initial is 0. Similarly, I can use v is equal to u plus at. So v final, u is 0, u is equal to 8. There, I get my v final and omega final. This is the way to do. You can't conserve energy there, and there is no relation between vf and omega final directly. You have to get the time and then use it. Till here it is clear. Now comes the third question. Work done by friction and work done by torque. Now, what is work done by friction? If you see in this system here, the work done by external forces is change in potential energy plus change in kinetic energy. So normal reaction will not do work. Mg is actually potential energy ka term, so there's only friction. So work done by friction, that is your only external force here. Mg, spring force and electrostatic force, all are internal forces. Change in potential energy, so final potential energy is 0, initial potential energy mgh. Change in kinetic energy, initial kinetic energy is 0, final kinetic energy half mv final square plus half I omega final square. This is your final kinetic energy minus 0. This is your work done by friction. And if you solve this, this will come out to be negative. And makes sense because you're losing energy or getting heat produced. Now, what is work done by torque? Now, tell me one thing. Can torque create translation motion? Torques are only useful for rotation, isn't it? So work done. So you can make a statement like this. Work done by all torques. Just like you say work done by all forces is change in kinetic energy. Work done by all torques is change in rotational kinetic energy. And the about center of mass, the only torque acting is center, friction. The work done by torque due to friction. Initially, omega is 0. This is half I omega final square. And interestingly, this will be positive. So what is this exactly? What is happening? Like, why is so this thing, right? If they ask you, this, you can also say this is the total work done by friction. That's the total work done by friction. And this rotation thing is only a part of this thing. So what is exactly happening? Look at this. When the ball is sliding, if you look at the friction, this friction is doing two things. One, it is stealing energy from translation. You're creating acceleration this way and velocity this way. You're stealing energy from translation. And what are you doing in return? You are trying to give energy to omega, isn't it? Because you're creating alpha in this direction. So friction is actually doing two things. It is trying to mess up your translation motion. It is also trying to change your rotational motion. So in this scenario, it is stealing energy from your translational kinetic energy and it is trying to give it to the rotational kinetic energy. Making sense? But unfortunately, what is happening, whatever you're stealing, you're unable to convert everything into rotational kinetic energy. It's like you're taking 100 rupees, but you're giving back only 40 rupees. So remaining 60 becomes waste. In case of a pure rotation, क्या होता है देखो? When the body is purely rotating, look at this bottommost point. Friction. This point will have velocity v and this point will have r omega. Agreed? So power due to friction will be minus F into V. So this is the energy you're stealing from translation every second. The power on rotation, so this is the energy you're giving to rotation every second, which is plus F into R omega. When there's no slipping, V is equal to R omega, these two will be exactly equal. That means you are converting all the translation energy which you're stealing into pure rotational energy there. But when there is slipping, you are missing out some energy and that becomes heat. I hope this was clear. So torque can do positive work, but the total work can be negative. So when you say this total work, this thing includes rotation plus translation. So the overall thing is negative. Clear? So that what makes this thing good one. So work done by torque is something else. Work done by friction is something else. Any doubts on this? Let's see. That's a one simple, easy concept. Good one. Not a. You can expect things like this also. मतलब ऐसा नहीं हर बार every question will be out of the world thing. It's still a good question, good concept. These kind of problems now we will do in SSM also again. So don't worry. These things will keep popping up anyways. This also you have done before in the class notes. This is another good question. So we have a solid cylinder. Mass m radius. This is a Planck. Mass m. So here we have a string which is tied around the cylinder. This string goes from here, goes over the pulley and comes back to the Planck. ये string है. The ground is smooth. There is no slipping between the cylinder and the Planck. Then someone started applying a force F. You're applying a constant force F. Find acceleration of the Planck, acceleration of the cylinder, omega alpha of the cylinder. And the total change in kinetic energy of the system after time t. System meaning cylinder plus Planck. I can even ask you find the friction between them. Yeah, you can play around. If this is the paragraph, I will do that only. I'll ask you acceleration of the Planck, acceleration of the cylinder, alpha cylinder, or then kinetic energy of the system. So if instead of the Planck, if they apply on the main pulley, we can pseudo force. Why do it in the ground frame? Na? See, use pseudo force when your observer is in a non-inertial frame. Don't apply pseudo force just because force is somewhere. The question always comes, where is your observer?
No, sir, if it's on the leftmost side, like instead
Yeah.
of all, if we just apply force there.
Where you want to apply force? Here.
No, instead of the wall on the left side, if you put one pulley and put a force there instead.
यहाँ पे बोल रही here.
हाँ, नहीं, to the नहीं horizontally.
So you want to keep the string here and you want to apply force F here, ऐसा?
नहीं, वो you join both of them by one pulley and वो pulley पे horizontal force.
So you're saying join them like this? ठीक है, you draw and send me later, we'll see. But still, pseudo force has nothing to do with. But ठीक है, भेजो देखते हैं. Start with the free body diagram. This is like thing you see a question like this. First thing you start with the free body diagram. You don't even think twice. You guys remember the process for solving step 1, choose your system, draw the FBD. Step 2, assign accelerations and alpha everywhere. Step 3, find relation between accelerations and alpha. Step 4, apply force equations and torque equations. Step 5, solve. Follow the process. When you follow the process, and sometimes when it doesn't work, you'll at least know which step you have to think about it. For the people who don't have a process, they will just go round, and that is how time goes away. That's the reason I keep telling you to send daily study reports. Some of you don't send, that's okay. We'll talk about that also. You should start sending. I'm scaring your juniors telling about you guys, how much you're working and how much you're struggling and all. And your juniors have become serious and they're studying 10, 12 hours on holidays. Okay, step 1. Let's see whether you got the free body diagram right. Cylinder, the plank. What are the forces? Force F, friction, tension. I'm not writing the vertical forces. N and mg anyway, that's not required because कुछ ऊपर नीचे मुंह तो नहीं कर रहा है. Yeah, I think these are the only forces. F, friction. नहीं, एक और है यहाँ पे. We have one more tension. F here, this is one, this is one, this is one, this is one. Yeah. This is the first thing. Forces are clear. Next thing, assign accelerations. Let the acceleration be AP. Let the cylinder go backward A, and let this thing also rotate with alpha. Perfect. Next thing, no slipping condition and string constraint. Now, if you look at the cylinder and the plank, at the bottommost point, you have an acceleration R alpha, and you have A, and this point is AP. This is the no slipping condition. No slipping condition is not A is equal to R alpha. What is no slipping condition? At the point of contact, the 2 points should have same velocity and acceleration. So R alpha minus acceleration is equal to AP. This is your no slipping condition. Next thing, if you look at the topmost point, this thing has an acceleration A plus R alpha. And this is connected to this point with a string. If these two accelerations are not same, then the string will either break or become loose. So acceleration along the string must be same. A plus R alpha must be equal to AP. This is your equation 2. This is the acceleration along the string must be same. This is your no slipping condition. And when you solve this, then you add the A and A will cancel. You'll end up with AP is equal to R alpha, and you will get A is equal to 0. So acceleration of the cylinder is gone. So interestingly, this cylinder is not translating. It is at the same place. It is just rotating at the same place and leaving string, and the plank is going away from the bottom. Making sense? That is your step 2. Step 3, apply the force equations. F, you can, now again, be careful. You cannot take torque about this point. Why? Torque about A will come, pseudo force will come now. So A is non-inertial, so don't take torque about that point. So when you're sure that A is on a floor and it has 0 acceleration, you can do that. So I'll not do that. So I'll take center of mass only. So torque about center of mass will be TR plus FR is equal to MR square by 2 alpha. T minus F is equal to 0 because AC is 0. F minus friction minus tension is equal to MAP. There, I think you'll get everything you want. How many variables are there? Tension, friction, AC, alpha, AP. 5 equations, 5 unknowns. Clear with this? You will get whatever you want here. Then how do you find the kinetic energy of the system at time t? Now, since I know the acceleration omega alpha, I can find V final, omega final after time t. And then I can find the kinetic energies. That is one way to do, but there's a much better way to do. On this entire system, what is the external force acting on the system? F. N is there, but N will not do any work, isn't it? So can I say like this? So work done by all forces is change in kinetic energy of the system. And the only force acting on the system which is pulling the whole thing is F. So what is work done by the force? F into displacement of the point of application of force. I hope everyone remembers the worker definition. I don't care about the displacement of the body. It's the displacement of the point of application of force. Anyway, it will be the same as the Planck in this case. This is your kinetic energy of the system. In this system, you have cylinder, you have everything. And what is the displacement of the Planck? Half into acceleration of the Planck into t square, na? That's okay, एक step में. There's no need to find omega, V and all that stuff. Are you getting the argument? The reason you are gaining energy, isn't it because of this F? There is no one else who is giving energy to the system. So F is giving energy. So work done by F must be the kinetic energy of the system. Clear with this? So there's no need to find omega, there's no need to find speeds or anything. You can just directly do it here and you'll get the answer. Any doubts on this? Clear with this? Take a 5-minute break. Come back by 7:30. We'll continue from here. Any doubts so far? Chalo, come back in 5 minutes. We have a trolley of mass m. There is a lot of sand piled up on top of it. So m is the mass of sand plus trolley. So there is a small hole here, and the sand is leaking here. And you're applying a constant force, and initial velocity is 0. Find the velocity of the trolley at time t. Now, in case people don't remember, we have something called F thrust, which is minus u relative dm by dt. U relative is the speed of the mass ejected with respect to the system or respect to the rocket. Rocket propulsion, basically. Variable mass system. Relative velocity. dm by dt is the mass ejected per second. Just to give you an idea how to use this is a standard model in rocket propulsion. So if you have a rocket and gas is being ejected, so if you look at the forces acting on the system, we have F, and let's say this is ejecting UR and at a rate of lambda kgs per second. And let's say initial velocity is 0. This is a straightforward question. Find the velocity of the rocket at time t. So the forces acting on the rocket will be, see, if the gas is coming out, you get a thrust force in the opposite direction, which is U relative into dm by dt is equal to, which is U or lambda. Interestingly, if you notice something, this is constant. Because the speed with which you're ejecting gas is constant, the amount of gas you're ejecting is also constant. So when the rocket gives out this much gas with a speed of UR, so this is the speed of the gas ejecting. You should check out the Centromusk variable mass system notes in case you have no idea about variable mass systems. So that is one force, and then the other force is mg and acceleration. So here the catch is m is changing. What is m? M is equal to m minus lambda t. As time passes, you're losing mass, so mass of the rocket is decreasing. So then you're done. So F thrust minus mg is equal to ma. This would be u into lambda by m will be m minus lambda t minus g is equal to dv by dt. You can integrate this. This would be u lambda integral dt by m minus lambda t minus gt 0 to t. That will be 1 minus lambda ln m minus lambda t. You can put the limits. Clear with this? This is the velocity of the rocket at time t. So this is your thrust force. Idea is the same. So we have a lot of sand on top of a trolley, and the trolley is applied a constant force. Now mass is changing, so you can't use the equation F is equal to ma. Remember, that's a blunder. F is equal to ma is derived under the assumption, right, that the mass is constant. So how do we do this? So let's say after time t, this is going with v. Now here, an important thing. I'll show you another question which looks like this, a little variation of it. That is different. So here, when the sand is falling down, right, the sand which is falling will also have the same speed as the trolley, isn't it? If you are going in a bus at a speed of 30 kilometers per hour, and if you jump from the bus, you have the same speed as the bus, right? So the leaking sand will have the same speed as the trolley. Therefore, V relative is zero. There's no thrust force, right? So the forces acting on this thing will be only F here. F is equal to, so this is F external plus F thrust is equal to ma. F thrust is zero. So F external is F and F thrust will be m minus lambda t into dv by dt. So you just directly get it. Zero to V and zero to T. Clear with this? Then you get that exponential and everything. So there is no thrust force here. When the sand is just leaking out, right? That's what you get there. Clear. Another variation of this was the other one. The sand is falling onto the trolley. We have a trolley, force F, m is the mass of the trolley. We have a container with a sand, and this sand is dripping onto the trolley. Sand falls and stick to the trolley. Lambda kgs per second. Same question. Find the velocity of the trolley at time t. So in the previous case, it is leaking out. Now it is leaking onto the trolley. Initially at rest. This is actually easy, okay? But let me show you both the ways. First, I'll show you a little lengthier one. Now, what are the forces acting on this? So this is F. Now the sand which is falling, the speed of the sand is zero. The trolley ka speed is, let's say, V. So the sand which is falling will have a zero speed. The trolley is going with V. So there is a V relative now. So when they stick here, they do exert a thrust force backward. So we write F minus F thrust, which is U into, which is V into dm by dt. This is F minus F thrust is U into lambda is equal to m plus lambda t into dv by dt. This is also V actually. because here V relative is nothing but the velocity of the trolley only. And this integration will be dV by F minus V lambda ka integral and dt by M plus lambda t ka integral, and then you will get it. There's a much better way. There's a faster way. And remember this thing, this will be useful in, I'll tell you what kind of question they'll come. After time t, look at the trolley ka situation. After time t, there'll be some sand on the trolley. How much? Lambda into t. What is mass of the trolley? Capital M. And you're applying force F. This is the time t. So can I directly say integral f dt is equal to change in momentum? F is constant, which is F into t. What is change in momentum? M final, V final minus M initial, V initial. Initially you're at rest, so 0. What is M final? M plus lambda t into V. Therefore, V final is equal to Ft by M plus lambda t. Here with this. Think about this. All the momentum this force F is giving is going only to the sand and the trolley, na? So force into time is the total change in momentum, which must be, and initially you're at rest, so that must be the total final momentum of the trolley plus the sand. You can integrate this by your answer. So my question is, why couldn't you do this for this scenario? When the sand is leaking, why couldn't you do that? Why couldn't you say that F into t is a change in momentum? Why couldn't I say here integral f dt is change in momentum? Meaning I can say, but why can't I solve with that? Normal is also acting on the sand. We are talking about horizontal momentum, record. Why are you talking about vertical normal? Sand is also part of the system. Yeah, sand is also part of the system. So, right, Aditya. Yeah, so here catch kya hai na? Look at this thing. Whatever is falling on the trolley, everything, the sand, this speed v which you wrote, right? All the particles of the sand will also have same speed v, agreed? But here when the sand is leaking, do you think all the sand has the same speed? The starting sand which leaked had a 0 speed. When the trolley started moving, that sand which leaked had a different speed. So every particle that is falling on the ground has different speed. So yeah, you can still write, okay, you can still write integral f dt is equal to change in momentum. That will be momentum of the trolley plus momentum of all the sand particles which has fallen on the ground, horizontal direction way. Is that making sense? But we cannot find that momentum of the sand on the ground, isn't it? So that's why it doesn't work here. You have to go with that integration thing. But here it works. And the best part about this method, right? If f is equal to t be diya na, your life is still easy, right? This will be simply t square by 2. Are you clear? So again, not a tough question, but yeah, be careful. It's a good one. Now, how can they frame this question in another way? Meaning, if you have seen something, you must have seen a model like this. Gravitation ka question is normally. There is a, a big cloud of dust. So this is also actually variable mass system. And they say, we have a cylinder or a spaceship kind of thing. So this is a cylinder here. So this cylinder is going with u. And as the cylinder is moving through the cloud of dust, what will happen? The dust particles get collected in front of the thing and the stick. Right? Cloud of dust, density, rho. Right? So when cylinder goes through the dust, it, what do you call it? They stick to the cylinder. And cylinder goes through dust. The particles stick. Right? So E is equal to 0 basically. And let's say this length of the cloud is L. And you're initially pushing, this is the capital M, and pushing with speed U initially. This is their initial speed. So I can ask you, like, what is the time taken to cross the cloud? Take other data, area of cross section A. You can take the length of the cylinder is very small compared to the cloud ka length. So find time taken to cross the cloud, or maybe find the speed when it reaches the other side of the cloud. So let's see, let's try to find the time. You should get something. I just made it up. Find time taken to cross the cloud. You'll get these kind of questions. But scenario समझ में आ रहा है ना? So it is no gravity, neglect gravity. So we have a spaceship in the form of a cylinder which is going with you through a cloud of dust. The density of the cloud is rho. I don't remember if you need any more data, but dekhte if you need more. So as this is passing through this thing, more and more dust particles are getting accumulated. So this thing is going to slow down. The speed is not constant. So how much time will it take for this to cross the cloud? This is also variable mass system. How do we start? Think of like this. Let's say it has already traveled x. So can I say all these dust particles which are there in this cylinder x must have got stuck to it? Getting it? So when the spaceship reaches here, let's make this thing a thin spaceship. So all this must be accumulated on the, all this mass is stuck. How much mass is this? Rho into A into X. So at this position, when it reaches here, let the velocity be V. Since there are no external force on the system, momentum is conserved. Mu is equal to M plus rho A X is equal to V. So V is equal to mu by M plus rho A X. Yeah, you're done. So that will be dx by dt. That will be mu dt is equal to M plus rho A X dx. These limits will go from 0 to L and these limits will go from 0 to time. ऐसा time आ जाएगा. Make sense? So you found the velocity as a function of x. Variable mass system. So why बोल रहा हूँ हर बार वो thrust force ही नहीं है. We can use integral f dt is change in momentum. So ask yourself, is there any external forces? No. Right? So integral f dt is always equal to change in momentum. You can use like this, or you can use this Sandwala problems. Clear? Then let me ask you one more on this. Let's say we have a rocket, mass m, going with speed v. There is no gravity, nothing, neglect gravity. Now, if you look at a rocket, right, they have main thrusters, they also have a side thrusters. So they have some side thrusters here. So these are actually used to, course correct your trajectory. If your rocket is going away in some direction, you can use this to change the directions. So all these rockets, right, when they're fired, these are side thrusters. All of them together are ejecting gas at a rate of speed UR lambda kgs per second. Getting it? So gas is ejected perpendicularly. So the side thrusters are perpendicular. perpendicular to velocity of the rocket. Now, when you do this, what will happen? This rocket will not go in a straight line anymore. The rocket will actually start deviating. Getting it? So you have a main thruster here that will increase your speed, but these are the side thrusters which are adjusted to the direction. So the rocket will become something like this after time t. So delta is your deviation of the rocket. Find delta as function of time t. You're getting the story? We have a rocket of mass n going with speed v. Suddenly you switched on the thrusters. There is no gravity, no vacuum, so ignore all other forces. The side thrusters are generating a force perpendicular to the rocket. So they are just trying to change the angle. And because of this, the rocket will start deviating. Find the angle deviated by the rocket after time t. I could ask you like this, find the rocket when it makes a U-turn 180 degrees. So delta is 180 then. How do you handle this? I'll show you again something like this in magnetism. This actually I got inspired from a magnetism problem. But yeah, let's see. No, there's no main thruster here. No? Rocket is going straight, you switch it on the side thrusters. The rocket started deviating. Find the angle deviated by the rocket at time t. Anyone didn't get the story or scenario, please ask. I'm keeping all this together. These are all variable mass problems. Think for a minute, then I'll tell you something and I'll give you one more minute. Someone got it? Prakruti. Yeah, UR is the speed of the gas with respect to the rocket. UR is always relative speed with respect to the rocket. Relative velocity of the gas with respect to the rocket. This thing, now the theory is here. You should definitely go through this. Yeah, this was there, page 195. F thrust and everything. So first word, see, look at this word here. The gas is ejected perpendicular to the velocity. If the force is perpendicular to the velocity, what happens to the speed? Speed remains constant. That means no matter how much this rocket is moving, the speed v will not change. So all this force is only used to change the direction. Isn't it? Because the moment the rocket bends, even the thrusters are bending, right? They always maintain 90 degrees. So the side thrusters can never increase the speed. They can only change the direction. Clear with this? Since the gas is always ejected perpendicular to the velocity, the force is perpendicular to the velocity, so the speed of the rocket remains constant. Speed, not the velocity. Now think, I'll give you a minute. That is the first thing. Once you got that, so that means this force is used for what exactly? Are you going in a circle? If not, then what? Let's see. नहीं रे फलक, साइन थीटा डी बाई आर वो नहीं है उसमें. साइन थीटा डी बाई आर में बी इज कांस्टेंट ना. So यहाँ पे we start the argument like this. Since u r is perpendicular to v bar, right? The force is perpendicular. F thrust is perpendicular to velocity. Therefore, speed of the rocket is constant. So all this force is used actually to the centripetal acceleration. So whenever you take this rocket here, which is going with speed v, so at any instant, you can treat this to be going in a circle with a radius r. So speed is constant, great. And what is this force acting here? The force is F. That must be equal to the centrifugal force mv square by r. So here the catch is the force is constant, speed is constant, but mass is not constant. So F is equal to mv square by r, right? This force is nothing but ur into lambda. Mass is nothing but m minus lambda t. You can do something better here. I don't want to play with that radius, so I will come. And the biggest thing is this. What am I asking you? Omega, right? Delta, right? I'm asking you for angle. I'm asking you to find angle as function of time t. So think about this. Where do you get angle as function of time t when omega is d theta by dt? So let's get that one. So mv square by r. So multiply. I don't want to bring r into the picture. So v by r is how much? Omega into v. Agreed? You're done. So you are lambda by m minus lambda t is equal to v. Omega is d theta by dt. V is constant. Yeah, everything is constant there. So we get d theta is equal to u r lambda by speed of the rocket dt by m minus lambda t integral 0 to delta 0 to t. We get delta is equal to minus ur by v ln m minus lambda t 0 to t. This will be ur by v ln m by m minus lambda t. That's your deviation as function of time t. Clear with this? So the thrust force is used as a centripetal acceleration. So you're going in a circle, and if you look at the radius, right, this radius is becoming smaller and smaller. The circles are becoming tighter and tighter because the mass is decreasing now continuously. So since m is decreasing, r also will keep decreasing. So in this equation, if you see f is constant, v is constant, so m is proportional to r. I can ask you that also. Find the radius of curvature as function of time t. This is not a circle. This is a path where the radius of curvature is becoming smaller and smaller. Clear with this? There. That is how you can use. Something similar here. Let's say we have a rod here. Mass m, length L, gravity is there. Here we have a small insect of mass m, which is going with speed u. It is observed. Now, because of the gravity, right, the rod should fall down. And if the rod is falling, the speed should increase. But we observe this insect, right, starts going with a certain speed u as function of the distance x. It is observed the rod maintains a constant omega. The insect moves on a rotating rod with u. Omega of the rod is constant. Now think about this. If there's a gravity, shouldn't the speed of the rod increase? Omega shouldn't be faster and faster. But for some reason, omega of the rod is constant. Find the speed of the insect as function of x and theta. So something is happening. Because of the insect going, something is happening. So we have an insect crawling on a rod with speed u along the rod. The rod started with omega, and for some reason, the rod maintains that omega. Find the speed of the insect as function of x and theta. So what is the catch here? Listen. Now let me tell you something. So F is equal to ma is a blunder. The actual equation F is equal to m dv by dt plus vdm by dt. Remember, F is actually dp by dt, isn't it? P is nothing but m into v, so product rule. Similarly, torque is equal to I alpha is a blunder. Torque is actually dl by dt. What is angular momentum? I omega. So that will be I d omega by dt plus omega di by dt. This is a variable moment of inertia of a system. So torque is equal to I alpha is valid when the moment of inertia of the system is constant. But when the insect is working on this, moment of inertia of the system is changing, isn't it? So similarly, ये याद है? EMF is equal to minus LdI by dt. Back EMF, EMI. That is not right. EMF is equal to d phi by dt. But what is flux? Minus Li. Minus L di by dt minus I dl by dt. So these three are constant under the assumption M is constant, I is constant, and L is constant. Getting it? These are the actual formulas. So if you have a variable self-inductance, you can't use the back EMF is LdI by dt. If you have variable moment of inertia, you can't use torque is equal to I alpha. If you have variable mass, you can't use F is equal to ma. Clear with this? So I think with that as a perspective, now it is easy to handle. So after time t, you can find the torque of the system. So the insect ka weight is mg. Rod is capital Mg. So torque will be mg L by 2 cos theta plus small mg x cos theta. I of the system will be ml square by 3 plus mx square. Di by dt will be 2mx dx by dt. The dx by dt is the velocity of the insect along the rod. And then you write torque is equal to I d omega by dt. So here d omega by dt is 0 plus omega di by dt. This term is gone. So substitute, you will get v from here. Easy? So there, variable mass, getting a thrust force, and then you have your variable moment of inertia. So later on, we'll see in EMI also, you have a variable self-inductance. So be careful with this. Most people think is LdI by dt. Not true. If you have a variable self-inductance, you can't use that. We have a disk here, mass m and radius r. This disk is going in a circle. You're getting how it is rotating? So the disk is going in a circle like this. This whole thing, the disk is rotating with omega naught. Let this length be L and let this radius be R. This is kind of like the previous question. Remember, ये question था, the ceiling fan, the table fan wala, rotating and going in this way. Same thing. Getting it? So we have a disk which is going in a circle with omega naught. Are you able to visualize how is the picture? So the wheel is rolling on this. So then it is turning here and it is going like this. All sure with this, the picture. Find omega of the disk and alpha of the disk. There is no slipping on the floor. A disk of mass m and radius r is rotating in a circle of L. So it is like your cycle ka wheel or car ka wheel. It is just rolling in that red circle without slipping. And it is straight. Find omega of the disk and alpha of the disk. How many omegas does the disk have? 2 omegas. So if you look at this disk, it has 1 omega in this direction. Omega 1, this is your rotation, and you have 1 omega in this direction, which is your revolution. I can say like that. Getting it? So if you look at this, omega of the disk is simply omega naught upward direction. I'll just put an upward arrow plus omega 1. I'll write it as r cap. R cap is the radial direction. So if you look at the top view, the omega 1 is actually going like this. This is your radial direction. Right? Omega naught is fine. So I just need to find omega 1. How do I get that? If you take this ring, since it is not slipping, this point is going with V is equal to L omega naught. And this point here, because now you're rotating with omega 1, this point is not slipping. So iska velocity hoga V center of mass, and ye piche hoga R omega 1. So V com minus R omega 1 must be 0. That will be L omega naught is equal to R omega 1. This comes from no slipping condition. L omega naught by R. So there, that's your omega of the disk. If you just want the magnitude, omega of the disk will be root over omega naught square plus omega 1 square, which is omega naught into root over 1 plus L square by R square. This is the magnitude of omega. But tell me one thing, is omega constant? This omega has 2 directions, omega naught and omega 1 R cap. This is a variable, right? The reason you're getting alpha is because of omega 1. Omega naught is constant. So far the story is clear. But there's something I want to teach you here. You can get the omega much faster. Then we'll talk about alpha. Now, when you remember that IAR, I told you how to find IAR. So how do you look at IAR? Draw perpendiculars to, you need to find at least 2 points. Draw perpendiculars to the velocity of any 2 points on the body. And the point of intersection is your IAR. But there's another way you can figure out an IAR. What if I can find 2 points with 0 velocity? Right? If you have 0 velocity, then there is a velocities are 0 vectors. Then the perpendiculars are the 0 vectors only, isn't it? So I can also do like this. Right? The line joining 2 points with 0 velocity is also an IAR. Now, the previous question, can I do like this? Can I assume if there is a thin rod in the middle and there is a disk here and you're rotating in a circle? Now, in this system, can you tell me 2 points with 0 velocity? One is this support. One is the bottommost point. Not slipping now. This is V0. This is V0. If I join these 2 points, this is your IAR. That means the total omega of the system is actually about this axis. And it depends on how you're drawing it. So like this, this whole rotation here, this is your omega of the system. Making sense? So where are you getting the 2 components from? One is your omega naught, and another, the disk rotation, this thing, is this omega 1. So actually omega 1 and omega naught ka completion is just omega of the system. You're getting it? Now look at this thing. If I take this angle to be theta, this angle to be theta, this is length L, this is radius R. I know theta, right? Now can I say like this? Omega system sine theta, isn't that omega naught? So this omega ka two components are omega 1 and omega naught, isn't it? Just think of like that. Just like you resolve velocities, you can resolve omegas also here. So from here, I can find omega of the system is nothing but omega naught by sine theta. And what is sine theta here? Sine theta is opposite side r by hypotenuse, which is root over L square plus r square, which is omega naught into root over 1 plus L square by r square. Isn't that the same thing? So if you can find 2 points, you can directly finish off with the IR there. Is that making sense? Now, if I ask you something similar, let's say, same question basically. If you have a cone like this, this is a smooth floor. So we have two solid cones like this. Okay. This is rotating with omega naught. This is rotating with omega naught. Can you tell me omega of the cone in both the cases? Assume you know everything, radius, length, everything you know. You're getting how is the picture? One cone is literally in contact here and the whole thing is sliding around. मतलब ये पूरा ऐसा rotate कर रहा है, ये ऐसा rotate कर रहा है. Are you able to get the cone how it is? I know my picture is not great, but I hope you got it. So this thing is something like this. So yeah, you got the picture. In both the cases, can you find omega of the cone? So step one, look at IAR. Why se start karo? What is the IAR here? You need to find at least 2 points on the body which have zero speed. Connect them, that is your IAR. So your total omega of the system is along that line. And uska components will be this omega naught and the omega revolution. Did you look at the IR? So first case mein, where are the points with zero speed? There is no slipping, right? So this point, literally every point on the floor is at rest, isn't it? All are at rest. So for this system, this is your IAR. Matlab omega of the system is in this direction. Got it? And so this rotation, right? You just have to be careful, okay, whether it is left or right. So ye omega naught you're writing in which direction? So if it is rotating this way, so if I assume this is rotating this way, omega dash, then the omega naught will be this way. So this is omega naught, this is omega dash, and this green thing here is omega system. दिख रहा है कैसा है? So there are two omegas. So omega dash is vertical and omega naught is this way. In दोनों का resultant is omega system this way. Yeah, someone is saying something?
So omega naught will be in the opposite side.
Then omega dash will be this side. तो my direction you can take ना then. Omega naught अगर ऐसा है तो omega dash नीचे होगा. ठीक है? I'm just, you take however you want. It doesn't matter. Science will take care. Because see, this is IAR, right? How do you know whether omega is this way or this way? It depends on omega naught का direction. मैंने सिर्फ वो change कर लिया. take it like before, kya? I'll do like before only, then wait. So I'll take omega naught like this. So ye hoga omega naught. That means this circle, when you're rotating, you have to rotate this way, omega dash. So ye hoga omega dash, and this will be omega of the system. Fair enough? If you take this angle to be theta, we will get omega of the system cos theta. Omega of the system will be omega naught cos theta, and omega naught sin theta will be equal to omega dash. Make sense? So omega naught and omega dash ka resultant is omega of the system. Clear with this? And if I can find omega of the system, I can use half IIR square, isn't it? How do you find the kinetic energy of the system? Half IIR omega square. What about this guy? This is actually like the previous one only. So this point and this point, so this is your IIR. So if you're assuming it is rotating this way, then this is your omega naught. Then this will rotate this way, this will be your omega dash, and this will be your omega system. This is same as the disk equation only. But is the idea clear, everyone? So now the 2018 question, if you see, right, now you'll understand what is happening there. So in this question there, where is the IIR? This is the IIR, na? So one, you're rotating this way, right? Depends on how you're rotating. So you can say you're rotating this way. So that is your omega naught. And second thing, you're rotating this way. That is your omega dash. So in दोनों का resultant ये omega of the system है ना? So there are two omegas for the system. So one is due to this rotation, revolution, and one is due to the self rotation. Clear with this? That is how you can think of, just like that omegas, you can do that. Abhi question हुआ नहीं, we still need to find the acceleration. Now, before jumping into that, let me teach you something about a little about vectors. What happens if you have a vector, vector of constant magnitude when it rotates? What happens? Let's say you have a vector a bar, right, is equal to constant. Magnitude is constant. So a bar dot a bar is equal to a square, constant. Differentiate on both sides. This will be a bar dot dA bar by dt. This is a mathematical way of showing dA bar by dt dot a bar is equal to 0. This means a bar dot dA bar by dt is equal to 0. That means a bar is perpendicular to dA bar. Means if you take a vector with a constant magnitude, and whenever you try to change the vector, the change in vector will be always perpendicular. And it kind of makes sense. Think about it. If you have a vector of a constant magnitude, and you're saying magnitude is constant, that means the only way it can move is in a circle, isn't it? You can change a vector by changing magnitude or by changing direction. Make sense? And if you come and tell me magnitude is constant, the only way you can move the vector is by changing the direction. So this is A initial, which is A initial, and let's say this is A final. Let's say this is a small angle d theta. Now the angle is so small, can I treat this thing as your dA bar? Which will be nothing but A into d theta. You can even write sine theta and prove that. So dA bar is nothing but A d theta, and the direction will be theta cap. Theta cap is your tangential direction. R cap is radial direction, theta cap is tangential direction. So when it differentiates this on both the sides, so dA bar by dt will be A d theta by dt, theta cap, and A d theta by dt is nothing but A omega. So that means if you have a vector A bar in the radial direction, the change in vector dA bar will be tangential direction, and the magnitude of the change in vector is A into omega. Is this making sense? I just used vectors here, and this is not the thing. We actually did this last time, but इतना mathematically नहीं बोला था मैंने. This guy, where are you? this question में, if you remember, ये part था. Remember this differentiation? I differentiated this thing is what? Isn't this r bar? The position vector. When I differentiated, did you see I got d theta by dt? वही था ना, omega हो गया. And this was a tangential direction, no? That same thing what I did in terms of cos theta I cap, sin theta j cap, I kept it in a more proper vector form. So whenever you differentiate a vector of constant magnitude, the change in vector dA by dt is nothing but the magnitude of the vector into the omega with what it is rotating. So it will be useful result whenever you're differentiating vectors of constant magnitude. Clear with this? Now using this logic, now if I try to solve this, what is alpha? Alpha will be d omega by dt. Omega naught though is anyway constant. Now that will be d omega 1 by dt. This is anyway 0. Now tell me one thing, is omega 1 magnitude changing? Omega 1 ka magnitude is constant. And omega 1 is rotating with what velocity? Omega 1 vector is rotating with omega 2, isn't it? So d omega 1 by dt will be omega 1 d theta by dt theta cap. That's your tangential direction. But what is d theta by dt? Omega 1 omega 2 theta cap. Make sense? Are you clear what we did there? Here omega 1, mod omega 1 is constant. Magnitude is constant, but the direction is changing. That means look at this question. Huh? You have alpha, which direction? Alpha is tangential. Alpha is going along the circle. Omegas are perpendicular to it. याद है? Last time someone was asking like, so torque along the axis कैसा हो गया? So if alpha is in this direction, isn't torque also in this direction? So torque is tangential. That was this thing which I showed you the picture. There. Now can you see? The torque is tangential. The angular momentums are perpendicular. So if you see, it is exact same question actually. This is your omega 2. This is your omega 1. This is your alpha. Is that making sense? You guys should definitely go through these questions. We will talk more about that omegas and alphas more, but is this idea clear? ये concept याद रखो. I'll teach you in vectors again. I'll ask you something there. I can ask you now also, big deal. I'll just ask you. So let's say we have a vector r cap, d r cap by dt. If you guys remember, d square r cap by dt square. d cube, matlab triple differential, dt cube, so on till d 2001 dr cap by dt 2001 का mod. How much is this? याद है किया था हमने ऐसा वेक्टर्स में? 0 नहीं रे, कुछ भी मत बोल. I can change this. I can say 2001, 2002, 2003, 2004. I can make 4 questions like that. R cap रे. R cap is a unit vector. Think about this. याद है तो next class we will see. I'll tell you on Wednesday. ठीक है, take a break. Go have your dinner. Come back by 9 o'clock. 9 o'clock we'll start our test. So any doubts, anything else you can stay back and ask, or else you're free to leave. So go have your dinner, take a little break, rest up a bit for